Okay, so quadratic functions are a big deal, so we're going to move on from vertex form if you're just given vertex form to what if you're given a quadratic function and it's not in vertex form. Some people never get past that and they just try to pull the vertex right out of standard form, and that won't work. You have to know how to find the vertex. So here are the steps, and I'm going to go through this example here. So when you're trying to find the vertex given standard form, you want to remember the vertex form, and I'll write this down many times today because that's what I did in high school. Is I kept writing it down while I was doing my homework, and I was memorizing it while I did that. Okay, so the first example, how do I find the maximum or minimum value? I wrote it that way on purpose. Some people get stumped right off the bat. The maximum and minimum value is the vertex. So if I ask you for the maximum or minimum value, I'm finding the vertex, okay, of this function. Now for the example that's coming later, I picked this function, but I want you to notice that it's missing a term. Y equals ax squared plus bx plus c. This is a is 1, x squared plus b is 4x, and it doesn't have a c, but just add a 0 there, and then you can see that this example works for all of them. Okay, this is in standard form. It's not in vertex form. It's in general form, otherwise known as standard form. So you have to do some steps to find the vertex. It's not staring at you like it is in vertex form. So here are the steps. Step 1, write down the values of a, b, and c. So 1 is a, and 4 is b, and c is 0. Step 2, find the x-coordinate of the vertex. It's known as h in this formula, but don't fall in love with h. I've had people fall in love with h and I can't get them out of love with it, and it messes them up. H is just the name in this formula. What we're doing is finding the x-coordinate of the vertex. The way you find the x-coordinate of the vertex is you memorize negative b over 2a. Okay, so b is 4. So negative b would be negative 4 divided by 2 times a, which is 1. So we have negative 4 over 2, which is negative 2. Now that's h in the formula. Alright, let's write down the formula. Like I said, I would do this a lot because I speak algebra and I know how hard it is. Some people don't speak algebra. I don't speak Spanish, even though I've had a lot of Spanish classes. But I let that talk to me. I write down the formula and it reminds me that I need a, and I have a, because did you notice that this a and that a are the same? That's not a coincidence. That will always be. And I need h, and I just found h, and now I need to find k. So it reminds me what I need to do. How do you find k? Well, the value of the y-coordinate, this is a concept you should understand. This isn't really an h, it's an x-coordinate. This is an x-coordinate, right? It's an input. And how do you find its y-coordinate partner? Well, you just plug it in. That's the next step, is you take this value that you found, negative b over 2a value, and you're just going to plug it into the function. So f of negative 2 equals negative 2 quantity squared plus 4 times negative 2. And you can use your calculator, but this time I'm going to do it without a calculator. This is 4 minus 8, which is negative 4. This is k in this formula, but all it really is, the main thing you need to understand, is the y-coordinate of the vertex. Okay, so my vertex is negative 2, negative 4. Okay, so step 1, a, b, and c. Step 2, h equals negative b over 2a. Step 3, plug what you got in for your x-coordinate in to find your y-coordinate. I skipped this step. Let's go back. The x-coordinate is the axis of symmetry. So sometimes people write negative 2. That's the axis of symmetry. No, that's a number. you want to get an axis of symmetry is a line, so it's a vertical line, so you want to make sure you put it in vertical line equation form. That's your axis of symmetry. Okay, so, and it doesn't ask us, I could have asked what's transformation form, it doesn't ask me, but I'll put it in there. The transformation form would be 1 times x minus a negative 2, which becomes x plus 2 quantity squared minus 4. These are equivalent equations. They're the same equation but different form. Okay. State is it a maximum or minimum? Well, that comes from A. A is 1. It's positive, so I like to sketch it so I don't mess up. So that's a minimum right there because it opens up. And now I can, let's just jot down this ordered pair, -2, -4. So now I can state the interval where it's increasing. It's increasing, it's going up as we go left to right. Don't look at the x's, the y coordinate. We're looking at interval notation here, the x's. So that's from when x is -2 to infinity is when it's increasing, and it's going down here, but that's starting over here, so when x is from -infinity and -2 is where it's decreasing. Okay, I already did that. Write the function in transformation or vertex form. It's right up there. Okay, so let's look at another example. Oh, excuse me, let's just keep going. All right. You have two forms of the same quadratic function as I mentioned. You have y equals x squared plus 4x plus 0, that's standard form. And you have y equals x plus 2 quantity squared plus, minus 4. I added this sentence because students weren't getting it. How do you go from standard form to vertex form? You use the negative b over 2a method. Okay, we just went over that. It's harder. Okay, that's new. How do you go from vertex form to standard form? You have to know how to go back and forth. It's the same equation. Well, we can multiply that out. That's why I call that the multiplied out form. So if we multiply this out, and I'm going to do it quickly, I'm going to use, there's that binomial squared. I said you'd see it about every lesson. Here it is. I'm going to square double square. So that's x squared plus x times 2 is 2x, double it, you get 4x plus 4, and then you have that minus 4, and 4 minus 4 is 0, and look what you end up with. So to go from vertex form back to standard or multiplied out form, you simply multiply it out. And you have to be really comfortable with that. You have to be as comfortable as the water, as H2O. H2O, when you're thirsty, you want it in liquid form. When you hurt your knee and you need to ice your knee, you want H2O in ice form. It's the same element, or whatever you call it, I'm no chem major, a molecule, but it's got different forms for your use. Same thing for quadratics. Standard form is useful. I'm going to show you how big a deal standard form is. Vertex form is useful. Vertex form will give you the vertex, but you can just stare at you. It would bite you if it could, the vertex, but not when it's in standard form. Okay, so they're different forms. All right, so let's keep going. The next thing you need to know, be able to do with a quadratic, is you need to be able to find the y-intercept. Well, this concept is not going to change. To find the y-intercept, remember, you're going to let x equal 0. So the y-intercept, you let x equal 0. And that's it. So you could use either form. Standard form's a little bit easier, but it's not that much harder. What happens when you put 0 in for x is these terms cancel, and so you get a y-intercept of 0, because you let x equal 0, 0, right? So it turns out that when it's in standard form, the y-intercept is staring at you. The y-intercept in standard form is always going to be the constant at the end, 0c. But don't let that stop you. If you were given a vertex form, you could multiply it out and let it stare at you, or you could simply plug 0 in for x. That's how you find a y-intercept. So if I plug 0 in for x here, I get 2 squared is 4 minus 4, I get 0. See, I get a y-intercept whether I'm given standard form or vertex form. But standard form, the vertex is the y-intercept is staring at you. It's the C term. Okay, this was really the big deal right here. How do you find the x-intercepts? This is where standard form takes center stage. The x-intercepts, remember, you find that by setting y equal to 0. And if I set y equal to 0, then what I've got is this. X squared plus 4x equals 0. It's a quadratic equation. It used to be y equals, now it's x squared plus 4x equals 0. And you may remember from another video, those are known as the zeros of the function. The x-intercepts are also called the zeros of the function in standard form. You have to have standard form to find the x-intercepts. Okay, so we've got this standard form equation set equal to 0, and how do you solve a quadratic? Well, 100% of the time it has to be set equal to 0. Check. 2, you want to try to factor it. Does it factor? Not the way you might think, not two binomials. It actually factors out by, you can factor using a GCF. There's an x in common. So this is actually an easier one to factor, and yet I have a lot of students just mess up on this one because it's a different method. Alright, once you factor it, remember you set each factor equal to 0. So x equals 0 or x plus 4 equals 0. So x equals 0 is one 0, and x equals negative 4 is another 0, also known as x-intercepts. So let's write them as x-intercepts, ordered pairs. So we have 0, 0, because we set y equal to 0, or negative 4, 0. Those are my x-intercepts. Okay, needed standard form to do that. Alright, now we're going to graph it, and usually we have 5 good points just from this method. We have one less because whenever your y-intercept is 0, 0, you're going to have an x-intercept. That's the same thing. But anyway, we can still graph it. So 0, 0 and negative 4, 0 are my x-intercepts, and my vertex is going to be negative 2, negative 4, halfway between those two always because of the axis of symmetry, and that's all we have. But if we use the translation idea that I taught you in the other video, this has a vertical stretch. It doesn't have a vertical stretch or shrink, so it looks just like y equals x squared except moved to the left 2 down 4. So I can go over 1 up 1, and that's going to be a point because the a value is found right here, over 1 up 1. It's symmetrical, so I can go left 1 up 1, and that gives me 5 good points. And now I have a real pretty looking graph here. Alright, let's move on to another one. Takes a lot of practice to do these quadratics. You have different forms, different tools. It's a lot of stuff, but practice it. Alright, A, put the function in transformation vertex form. Let's let the algebra talk to us. What is transformation form? I write that down. I've got that memorized. That reminds me what to do. I need A. Well, A is 2. So I have that. B is 8. C is negative 10. So I have A. How do I find H? H is negative B over 2A. Memorize that. So if 8 is B, then negative 8 is negative B over 2 times 2, which is negative 8 over 4, which is negative 2. That's my H. That goes right there. Don't fall in love with H. It's really just the x coordinate of the vertex. So how do I find this guy's y coordinate partner? This is the way functions work. If I know the input, then I can plug it in and I can find the output. So I write this down on my paper. This is mandatory. Show your work right there. Okay, so I'm going to pick up my calculator, and since I wrote that so nicely with parentheses, all I have to do is type in. I have to be a good typist. 2 parentheses negative 2 parentheses squared plus 8 parentheses negative 2 minus 10, and I get negative 18. And that's my K value that goes right there, but more importantly, that's the Y coordinate of the vertex. Okay, this time it says put the function in transformation form, so I'll finish that out. It's called an f of x function, so I'll keep it f of x equals a, which is 2, times x minus, that's part of the formula, see that? That minus isn't that negative. X minus a negative 2 is going to turn that to plus 2, quantity squared minus 18. So that's my transformation form. The vertex is negative 2, negative 18, but I just worded this a little differently to remind you. Find the maximum or minimum. First of all, is this a maximum or minimum? Well, this 2 is positive, so it opens up, so the vertex is a minimum. So this is a minimum. And remember, the y coordinate, y value is what the minimum of the function is. It's the lowest value of the function. So negative 18 is a minimum, and it happens when x equals negative 2. So I just worded that a little bit differently so you could remember that y is the minimum. Okay, I'm sketching it right here so I can answer this question correctly. Where's the function increasing? It's increasing from when x is negative 2 to infinity, and it's decreasing from negative infinity to when x is negative 2. Now, how do we find the horizontal or x-intercept? Sometimes you'll see that. That means x-intercepts because x is your horizontal axis. How do we do that? You need standard form. You have to remember the x-intercepts are found by setting y equal to 0. So we're going to take this function, 2x squared plus 8x minus 10, and set it equal to 0. And that's a quadratic equation that you can factor. So we can review factoring. Before you start factoring with the trial and error method, check to see if you can pull something out. Can't pull an x out, that doesn't have an x, but you can pull a 2 out, and that's going to make it a whole lot easier to factor. So we have 2 times x squared plus 4x minus 5, and now let's factor. The factors of 5 are just 1 and 5, and we need to figure out which one to subtract to be 4. So that's x plus 5x minus 1. After you factor, you set each of the factors equal to 0. This 2 is not a factor. In fact, you can divide it out. Be careful when you do this though, because you can only do this within this context. If you keep using this with the 2 gone, you will change the function. You will lose the vertical stretch. But you can divide it out because right now I'm just trying to find the zeros. So I get x is negative 5 is 1 0, and x is 1 is another 0. So the x-intercepts are the order paired negative 5 0, because I put y 0 in for y, and 1 0. How would you find the y-intercept or the vertical intercept? Remember, that's you set x equal to 0. You've got standard form, so if you put 0 here and here, they go away. There is your y-intercept. It's staring at you when it's in standard form. But if I gave you vertex form and I asked you to find the y-intercept, that's when this kicks in. If you put 0 in here, you get 2. 2 squared is 4. 2 times 4 is 8. 8 minus 18 is negative 10. You're going to be able to get the y-intercept with either form. It's the x-intercepts where the standard form is super, super important. Okay, now we're ready to graph it. Notice that I'm counting by 2's on the x-axis and 5's on the y-axis. That's okay to do as long as you number it. So I've got my vertex, -2, -18. I have my X-intercepts, -5, 0, and 1, 0. And this time, see, this is kind of nice. I have an extra point that I didn't have in the other one. 0, -10 is my Y-intercept. And this is what I'm saying. The axis of symmetry is kind of helpful, because if I know that 0, -10 and it's 5 away from the axis of symmetry, then I know that there's another point here at -2, -10. And 5 good points is really all you need to get a really pretty looking graph. Don't forget, be neat. Make sure it's a U-shaped graph. That's a concept. And there you go. Okay, last example. So we have f of x equals x squared minus 8x plus 10. You should try it. Turn the video off and try it. Alright, I'm going to continue. Put the function in transformation form. So I write down transformation form. I'm memorizing it as I go. It reminds me what to do. I need a. Well, a is 1. B is -8. C is 10. Got a. I need h. H is -b over 2a. B is -8, so the opposite of -8 is 8. And then over 2 times 1, so we get 4. That's h. Please don't fall in love with that h. That's just the notation here. That's the x coordinate of the vertex. To find the y coordinate of the vertex, you plug that input into the function. So f of 4 equals 4 squared minus 8 times 4 plus 10. If you used your calculator, you should have gotten 16 minus 32 is -16 plus 10, -6. That's k, or the y coordinate of the vertex. So transformation form would be f of x equals a, which is 1, times x minus 4, quantity squared, minus 6. There is our transformation or vertex form. The maximum or minimum value of the function. Well, this function opens up since a is positive. So the minimum is -6. That's the lowest that function's value will ever get. It happens when x is 4. Find the horizontal intercept or x-intercepts. So we need standard form, and we're going to set standard form equal to 0 because we're finding the x-intercept, so we're setting y equal to 0. And if we try to factor this, the factors of 10 are 1 and 10. They don't add to be 8. Or 2 and 5. They don't add to be 8. So this is our final concept for the day. If the function doesn't factor, we have something called the quadratic formula that we can use to find the values of x another way. And the quadratic formula has to be in standard form, so make sure you get it out of vertex form before you use the quadratic formula. And the quadratic formula is that x equals -b, or opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So you have to have that memorized. So a is 1, b is -8, c is 10. So the quadratic formula is -b, so the opposite of b would be 8, plus or minus the square root of, this gets people into so much trouble because they write this down like this and then they put it in the calculator like that, and then it's wrong. If you write that down, you need parentheses around it, because a negative squared, quantity squared is positive, but the calculator will give you a -64 when you put it in as -8 squared, because it follows PEMDAS. It'll do exponents first. Okay, so what I do is I just square that in my head. I know my perfect squares. So b squared would be -8 squared. That's positive 64 minus 4 times a, which is 1, times c, which is 10, all of it over, not just that part, all of it over 2 times a, which is 1. So x equals 8 plus or minus square root. I typically teach students to do that. The calculator will do a lot for you, but I'd rather you break it apart. So I don't put the radical in because I want exact answers. I'm just going to put what's under the radical in. 64 minus 4 times 10 gives me 24, or negative 8 quantity squared. Like I said, minus 4 times 10 gives me 24, but negative 8 squared minus 4 times 10 is going to give me the wrong answer, because negative 8 squared is negative 64. Negative 8 quantity squared is positive 64, so don't make that mistake. Anyway, we have 24, what was it? Yeah, 24 underneath the radical, all over 2. I'm going to break it down by hand. We have to keep going because this radical right here can be simplified because there's a perfect square in here. 24 is 4 times 6. Okay, and 4 is a perfect square. So square root of 24 is really the square root of 4, which is 2, times the square root of 6 over 2. Okay, the other thing, this is a grouping symbol. Who's this 2 belong to? Belongs to both of them. Okay, so 8 divided by 2 is 4. 2 root 6 divided by 2 is 1 root 6. Okay, so my x-intercepts here are 4 plus square root of 6 comma 0, 4 minus square root of 6 comma 0. Those are exact answers, and if it's not a word problem, I need the exact answers. Okay, now there's a lot of things that I can tell you about this, and that this calculator will do the whole thing. So if you put in this division key and you get it this far, 8 plus the square root of 24, and then divide by 2, it will simplify that for you. But remember, you have to know it's plus or minus. So you want to be kind of doing a combination of the calculator and your knowledge. Okay. And it says find the y-intercept. So the y-intercept you find by setting x equals 0. So that's gone, that's gone. The y-intercept is 0, 10. And then it says graph. So we have a vertex of 4, negative 6. We have a y-intercept of 0, 10, which means because of good old axis of symmetry, that's 4 units away, so 1, 2, 3, 4. So we have another point there. How do we get those graphed? Well, I don't want you to give me the approximate answer. I want the exact answer, but we may need to figure out what that is. It's approximately 6.45, so we can put it on the graph. So here's 6, here's 7. So that's approximately where square root of 6 plus 4 is, and then 4 minus the square root of 6. Remember, the radical's got the negative plus or minus in front of it, is 1.55. So about right there. So we needed to do that so we could get the graph, and then we connect the dots. All right. I did add that one example here because, again, example 4, you have to look at negative 3 parentheses x minus 2 quantity squared plus 7 and notice that it's already in transformation form. And the number of people who don't recognize that it is high. The vertex is staring at you right in the face. The vertex, it's opening down, and the vertex, because of the negative a, is 2, 7. So this is a maximum of 7, and it occurs when x is 2. Okay, but how do I get the rest of it? All right, how do I find the x-intercepts when it's in vertex form? Well, you still have to set it equal to 0. And some people know how to solve that a different way, but again, that's not standard form. So remember, you can put it in standard form negative 3 square double square, that's x squared minus 4x plus 4 plus 7 equals 0. Distribute the negative 3, that's negative 3x squared plus 12x minus 12 plus 7 equals 0. That's negative 3x squared plus 12x minus 5 equals 0. Okay, now I know this is going long, but I do want to say one more thing, and that is I'm going to use the quadratic formula here, and I do not like to use the quadratic formula when my a value is negative. So when my a value is negative, I'm going to just divide out or multiply both sides by -1. That's perfectly legal, and that'll become 3x squared minus 12x plus 5 equals 0. So then I can use the quadratic formula. Negative b, 12, plus or minus the square root of b squared, which would be positive 144, minus 4 times 3 times 5, all of that over 2 times 3. That equals 12 plus or minus square root. I like to do that. Sorry, I'm going off screen. And then 144 minus 4 times 3 times 5 is 84 over 6. And then reduce that. So now I'm going to let the calculator do that. Remember, you hit this little sideways division key and just type in 12 plus the square root of 84 over 6, and it reduces it for you. That reduces to 6 plus, put the real part first, 6 plus square root of 21 over 3. So this is 6 plus or minus square root of 21 all over 3. So where that came from is 84 divided by 2 is 42. Well, that divides by 2. See, so 84 is 4 times 21. So the square root of 4 is 2, so that's 12 plus or minus 2 root 21 over 6. Well, what goes in to the 12 and the 2 and the 6? 2 does, right? So 12 divided by 2 is 6. 2 divided by 2 is 1. 6 divided by 2 is 3. So these are my x-intercepts. These are my zeros. Alright, and so then finally the y-intercept. We don't have a standard form. Oh, be careful, don't use this standard form. Don't do it. Because I changed it. I manipulated it. I multiplied out by a -1. So be careful. That is a common error. I'm thinking of, I said this in class, and then a student, I know the name of the student who did it. It's usually my smart ones, but this is a changed function. I changed it. So go back to the beginning to find the y-intercept. Remember, all you have to do is put 0 in for x. So -3 times 0 minus 2, quantity squared plus 7 is -3 times 4 plus 7 is -12 plus 7 is -5. The y-intercept is 0, -5. If you look at that, that's wrong, see? Because I changed it when I told you to get rid of the negative in the front. Okay, so let's graph it. We have a vertex of 2, 7. It's going down. We have a y-intercept of -5. We have to figure out where these x coordinates are. So I'm scrolling up and grabbing it so I can just hit the, oops, doesn't like to do it that way. Hit enter and then hit the squiggle. So we're talking 3.53 and then oops, well, can't get it. I'll type it over again. So then we have 6 minus the square root of 21 divided by 3 and squiggle 0.47. Okay. It's opening down, remember. Does that look right? Sometimes people will make a mistake and then maybe do a mistake with that 5 and get the y-intercept up here. You know it's supposed to shape like a U. Is that going to give you a U shape? Yeah, find your error before you give me something crazy. Alright. I even like when students say, I know that's not right. I could not find my error. And then you get partial credit for that. Alright, so there's that one. I threw this extra one on here. Might as well go through it. This is from WebAssign. Given f of x equals 1x squared plus a really strange 2 square root of 2x, that's b, minus 3, that's c. Find the axis of symmetry and the x-intercepts. Okay, well, how do you find the x-intercepts? Don't worry about that. How do you find the x-intercepts? You set this equal to 0, and can you use the quadratic formula? Yeah, negative b, negative 2 square root of 2, plus or minus the square root of b squared. So let's put that in there. 2 square root of 2, parentheses 2 square root of 2. Oops, make sure you get that parentheses on the right spot. Square it and look what you get. You get just 8. Alright, minus 4 times a times c, which is negative 3, all over 2 times a. Gives you negative 2 square root of 2 plus or minus the square root of, you can put that in the calculator, but I'm going to do it quickly, 20, square root of 20 over 2, which is negative 2 square root of 2 plus or minus, you can use the calculator if you want, but while I'm using the calculator, square root of 20 is 4 times 5, so no wonder it's 2 root 5 all over 2. And those are your x-intercepts. Not the prettiest x-intercepts, but that's it. Those are the x-intercepts. The axis of symmetry, remember, comes from the h, and the h comes from negative b over 2a. So negative b would be negative 2 root 2 over 2 times 1, which is negative root 2. So the axis of symmetry is x equal negative square root of 2. I like that problem because it tests whether you know the concept or not. And try to get used to the fact that if there's some weird number, a fraction or a radical, that's arithmetic. The calculator will help you with that. But the concept doesn't change. How do you find the x-intercept? You set it equal to 0, use the quadratic formula. How do you find the axis of symmetry? You find the x-coordinate of the vertex, put it in vertical line equation form.